All right, today we're going to do 7.3 day 2, which is still in logarithmic functions, but today what we're going to do is evaluate them. We are going to make them into another number. We're going to solve them, if you will, but we're going to evaluate them in their proper forms. But the first thing we got to talk about is common log and natural logs. Common log has a base of 10, which means that this here is the base, but it's not going to be seen there. You notice it's not written there. So that's base 10 is not written, just like the square root or just like the 1 in front of an x, or something like that. It's not written, it's common. Now common, because that's what's going to be in your calculator. When you do these, you're going to see them in base 10 in your calculator, and you won't see that base there. But just so you know, if you don't see something, it is a 10. All right. Natural log, which is with a base e, what you really get here is that log base e, okay, is actually equal to ln. Okay, so a lot of people think this is a 1. This is an ln for, well, backwards natural log. So natural log is really log base e. So, and that's also not going to be seen there. That I don't write that there because the ln is assumed e, base e. Ln is the base e. Okay, so these are the two that we work with. These are the two that we consistently will be using, just these two bases here. But later on, we have to change those bases, but that's later. Today, we're just going to evaluate, and with a calculator is really easy. When you go with a calculator, all you're going to do is type it into a calculator. So log 15, so remember this is log base 10 of 15. I wrote it in there to show you, but it's not going to be there when you get to the calculator. Here's your calculator. Log is directly next to 7, so I'll press it. So you see it changed, and then we said log of 15. And that is 1.17609. We're just going to say 1.18. So, sorry about that. So 1.18 for log of 15. The natural log of 15, again, in your calculator, the natural log is ln, right next to 4 and right below log, right here, ln. And then I'll just put 15 in, press enter, and you get 2.71. That's rounded 2.71. So 2.71. So that's how you do it with a calculator. Super easy, super convenient and fast and no big deal. Okay, so that's what you're going to see today a little bit with a calculator. You just type it out and you press enter. But when you don't have a base 10 or a base e, for example, it's a little different. You're going to have to show your work. So it's to evaluate without a calculator, okay? Without a calculator. So without a calculator, we have to rewrite these like we did before in the first part of the lesson. So we're just going to pretend this equals an x for the exponent. So this will be 5 to the x equals 25. That's what we did last week. We rewrote these problems here. So 5 to the x equals 25. So what you got to do is use your knowledge of what you know, and 5 to the what is 25. Well, if you know how to do this, 5 squared, 5 to the 2 is 25. All right, so let's do this one. So pretend this equals x, and so 3 to the what is 27. All right, well, let's say that you don't know what that is. Let's say I don't know. I have no clue. Let's go to your calculator, clear it out, and we're just going to take a guess here. So 3 to the 2, let's say, well, that's 9. What about 3 to the 3? What does that give me? Well, that gives me 27. So we go back here and we say, well, we do know the answer. It's 3, right? That's how you do it. That's how you do this stuff. So moving on to, let's go this one here. Remember that this is a log with a 10 here. There's a little base 10 there that you don't see. So that's 10 to the, pretend this equals x, to the x equals 10 to the what? Well, that one's really easy. Since they have the same base, then they have to be 1. 10 to the 1 is 10. All right, let's go here. 3 to the what is 9. So log base 3 of 9 means 3 to the what is 9. Well, you should have seen that just a second ago. That is 2. All right, so now if we go over here, this one's a little different. So if I go equals x, we have to see and think about what created this fraction. 2 to the what equals 1/8, or a fraction. And if you remember from our exponent rules, it's negative. So if I go to my calculator saying that I don't know, I go 2 to the negative 1, let's say, and then math enter will give you 1/2. 2 to the negative 2, and again, this is just guessing of what you think it might be. There's 1/4. 2 to the negative 3, if I press math enter, I get 1/8. So the answer is negative 3. 2 to the negative 3 is 1/8. So my answer, negative 3. So you go ahead and do this one. So I'll equal x. 2 to the x equals 1/16. So what do we see here? 2 to the what is 1/16. Go ahead and try it out. And the answer is negative 4. Because 2 to the negative 4 is 1/16. Okay. All right. Oh, sorry about that. And these last two are of course, the more difficult ones. Log base 4 of 32. So if I equal this to x, okay, what we need to do is realize something. If I go to a calculator, I'm not going to get 32. So I'm going to show you real quick. 4 squared, 4 to the third, 4 to the fourth. I'm not getting 32. You can see that. So the base needs to be changed. And what could we change the base to get to 32? Well, it would be silly to get bigger, like 5 or 6. So if we go to 2, because we know that 2 squared is 4, then we can get a base of 32. And I'm just going to make up a letter here. This is just making it up, just putting a W there. Now this base 2 is 32. All right, well, what does that make? Well, let's see. 2 to the third is 8, 2 to the fourth, 2 to the fifth, and there it is. So 2 to the fifth is 32. So again, I'm just guessing here. So rewriting this, we get, let me get my red back, 2 to the 2x equals 2 to the fifth. 32 is 2 to the fifth, 2 squared is 4. Same base now. That's what we have. 4 doesn't give you 32. We have to change it to 2. Now what you do, because you have the same base, you can set these equal to each other. So then you would say 2x equals 5, and then you divide by 2, and you get x is 5/2, or if you want to write it as a decimal, 2.5. Okay, but that's it. You don't even need the x there, to be honest with you. It's just 5/2. You don't. You want to see that this works. What you want to do, and I'll look at the original here. Let me go to green for a second. If we go back to the original here, this guy here, the rewrite, I can go in my calculator and check it. 4 to the, and what was it, 5/2, right? 4 to the 5/2 better give me 32, and it does. There it is. So we're good. That's the answer. All right, one more. All right, so this is pretend it equals x. Again, this is how we rewrite. We do without a calculator. 1/2 to the x equals 16. Well, 1/2, guys. Remember, 1/2. Fractions in exponent world is actually a negative exponent. So what we do is we're going to flip this guy. We're going to flip him, and we're going to change that to a half. So go to my blue. So this is 2 to the negative x equals 16. And if you remember, 2 to the 4 is equal to 16. Oh, I'm sorry. I wrote the wrong thing in the wrong spot. Sorry about that. This is still negative x. But 2 to the 4 is 16. And again, if you didn't know that, go to a calculator and press 2 squared, 2 to the third, 2 to the fourth, you'll get 16. So that means that negative x equals 4. Well, that means that x, again, we know it's going to be a negative exponent. X equals negative 4. And there you go. That's how you do it. Okay, so that's how we rewrite, and make sure the bases are the same. Do your work, and we'll see you next time.